Hello everyone. This presentation discusses the design and HFSS analysis of a cavity-backed slot antenna array operating at 10 GHz frequency. I will explain the antenna structure, key antenna parameters such as gain, bandwidth, polarization, radiation resistance, directivity, current distribution, and how each of these is verified using HFSS plots. The purpose of this antenna is at X-band frequencies like 10 GHz, we require antennas with high gain, directional radiation, and minimal back lobes. A cavity-backed slot antenna satisfies these by using a metallic cavity to suppress backward radiation and an array of slots to increase gain and directivity. This makes it suitable for radar and satellite links. What is cavity-backed slot antenna? A slot antenna radiates due to magnetic currents formed across the slot based on Babinet's principle. When we place a metallic cavity behind the slot, it prevents radiation in the backward direction and forces energy forward, improving performance. This is the geometrical overview of a slot antenna. This slide shows the reflector, the cavity walls, and the slot antenna array on the top surface. This cavity acts like a resonator, while the slots acts as a radiating elements arranged as an array. These are the physical dimensions used in the design. The slot length, width, spacing, and cavity depth are chosen such as that resonance occurs near 10 GHz frequency. Return loss indicates how much power is reflected back. A good antenna has S11 below minus 10 dB. From this plot we can see that at 10 GHz frequency the return loss is around minus 30 dB, which means almost all power is delivered to the antenna with very little reflection. Bandwidth is the frequency range where S11 is below minus 10 dB. From the graph, this occurs approximately from 9.6 GHz to 10.8 GHz frequency, indicates a good operational bandwidth around the design frequency. Voltage standing wave ratio measures standing waves. Ideal value is 1. From the plot we can see this voltage standing wave ratio is about 1.6 at 10 GHz, confirming excellent impedance matching. The Smith chart shows input impedance at 10 GHz frequency. The curve passes near the center, indicating the antenna impedance is close to 50 ohms, which matches the field line. Gain tells how strongly the antenna radiates in a direction. From the 3D plot, the maximum gain is about 16.89 dB. The high gain is achieved due to slot array and cavity backing. Directivity indicates how focused the radiation is. The narrow beam around 0 degrees shows that energy is concentrated in one direction.
At 10 GHz, the 2D pattern shows a strong main lobe at 0 degrees and very small side lobes. This confirms proper array operation at the design frequency. At 5 GHz, the radiation pattern is distorted with large side lobes. This is because the antenna is not electrically tuned for this frequency. At 15 GHz, more ripples appear in the pattern due to the increase in electrical spacing between slots, causing unwanted side lobes. The 3D radiation pattern shows radiation only in the forward direction. The back lobe is highly suppressed due to the cavity. We couldn't get the picture in the HFSS, but generally as per our study, it indicates in this way. What is polarization? Polarization refers to the orientation of the electric field. In the slot antenna generally produce linear polarization depending upon the slot orientation. What is axial ratio? The axial ratio indicates polarization quality. The lower value near 10 GHz shows stable and pure polarization at the designed frequency. This plot shows one polarization component dominating, confirming consistent polarization behavior across the angles. What is radiation resistance? Actually, the radiation resistance is a portion of input resistance that radiate power. Since S11 is very low, most input power is radiated, indicating good radiation resistance. The surface current plot shows strong current across slot edges, confirming that the slots are the main radiating elements. Current on cavity walls assist in reflecting energy forward. We couldn't get this actual plot in the HFSS, but generally as per our study from the other resources, it indicates in this way. The cavity is the most important in this slot antenna. It plays a crucial role and differentiate it from the other antennas. The role of cavity is that it prevents back radiation, improves gain and stabilizes the radiation pattern. This is how variety it is from the other antennas. So to summarize, the antenna shows high gain, good bandwidth, excellent matching, directional radiation and stable polarization at 10 GHz frequency. Applications. Such antennas are widely used in X-band radar, satellite communication, microwave links and defense applications where high directivity is required. And thank you.